just here to help orientate you and tell you I still love you, okay? And get you going again. So, Batseba, you can now take over for me. You can share your PowerPoint and then off you go.
Wait. Oh, okay. So now I can.
Now you share screen again.
Okay, share screen. Make sure it's on my PowerPoint.
Yep.
Share. How will I do this one?
So if you want to play the PowerPoint bottom right.
Now, how do I minimize this? Okay. There's something on my screen. I don't know. Okay, let me just go. Oh no. Wait. I think. Okay, wait. Is this a Mickey? Can you hear me?
I can.
Yes. This Okay, I can see something on the left side of my screen. Let me see something first. Slideshow. Okay.
Okay, you good to go.
Wait. One more thing. I just want to know, can the students see what's on? Because I'm not sure if that's the chat or.
I can see your PowerPoint. You are good to go.
So so you only see the PowerPoint.
Yes.
So I can't see this chat anymore. Okay, let me see. Chat. Okay, I can see the chat now. Okay.
All right, guys. I want you to be awesome. I want you to behave. Okay. I will also get feedback if you don't. And I hope you have a ton of fun. Okay. I'm going to gently, quietly stick around for a little bit. Okay. But I definitely will see you for the next one. All right, Baseba, class is all yours.
Okay, thank you so much, Mickey. Hi, everyone. I'm Baseba, and I'm sorry if I keep moving because it's actually my first time on Zoom, and I'm still trying to find the hang of how everything works. And again, my name is Baseba, and I'm going to be taking on grade 12 mathematics from Gratian. I hope you were having a great time with him, and I hope you're going to have a great time with me. So one thing you need to note is that you'll be on mute most of the time. For those of you who's having a first session. So you're going to be on mute most of the time. And then I'm going to go through your questions later. And then, yeah. So today we're starting with a new topic, which is differential calculus. So if you have any questions while I'm still going through the slides, just write the question on the chat, and then I'll try to multitask and make sure that I check your questions as well as explain while I'm going through the slides. So our topic for today is differential calculus. And there's something important that I want you guys to remember. Let me see. Is that maths is the only place where people buy 64 watermelons and no one ever wonders why. So it's practically a subject where we do things and then people just wonder, why are we even doing this? Then, yeah. So first of all, I want you to note that how we're going to have the sessions is that we're going to go through the content first, and then I'm going to give you examples, and then I'm going to give you homework for you guys to do. And then also we're going to go through question papers as practice for the exam. So as much as we do examples and problems in the textbook, we also need to do the question paper so that we can see what the examiners require from us. Okay, the first thing that you also need to remember is the problem solving process. So the first thing that you need to do is to read your question carefully. So if you have a question and it's 20 marks, rather spend a good 2 minutes understanding what is required from you. So while you're busy reading the question, highlight and underline the important words in the problem, and then the important questions that you need to ask yourself while you read the question is that what is given? Because usually in question papers, the question sort of hints what is given and what is required from you, identifying the problem. And then also you need, after you've read the question carefully, you've underlined the important words that are familiar. You need to ask yourself these questions, these 2 questions, and then if it's a word problem, for example, you'll translate the words to equations or graphs. And then, sorry about that. The 5th step, you need to choose a suitable method to apply to the problem. So if it's not given, like solve using a limit or whatever, you need to know which method is applicable for your question. And then after you picked the correct method to apply into your question, you will do the calculations, and then after you can check your solutions. For example, you can, if let's say it's factorization, you can take one of your answer and substitute it back into the equation and see if you'll get 0. Okay. So, like I said, our topic for today is differential calculus. And the important thing we need to know that calculus is simply a unit in mathematics, and it simply just helps you to calculate the rate of change of one quantity with regards to another. So I gave you a few examples here. For those of you who are doing physics, for example, you know that when we calculate the speed of an object, we usually check the change in displacement. Okay, we check the change in displacement with regards to time. So we're actually doing differential calculus without even realizing it. And then in another, let's say, for example, biology. Sorry for the typo. For example, in our case right now, we have COVID virus. So people need to check every day how many people tested positive and the rate at which the virus is growing. So these people are actually applying differential calculus and also without realizing it. Okay. And then this is actually, I know it's written at the end of the lesson, but what you need to take note of is that this is actually the basics of the chapter we're going to be dealing with. And then once we understand the basics, then we can go through the calculations, the detailed calculations. So what we're going to do is to define the limit of a function and to determine whether the limit of a function exists or not, and to apply the concept of a limit to derive a formula of which we're going to use to calculate the slope at a point on a curve. And then we're going to use the formula that we derived. Oh, sorry about that. Yes. So we're going to use the formula. So remember, we're going to derive a formula. Sorry. So we're going to derive a formula. And then after deriving the formula, we're going to use that formula to calculate the slope. So we're not going to just rush into doing the calculations. We have to do a few derivations. And then after doing the derivations, then we use the formula that we derived. And then at the end, we're going to find the derivative of a function from first principles. I know most of the words are probably new, but then within the lesson, I'm going to give you guys a chance to tell me if you need to explain something further that you didn't understand. Okay, so moving on. Okay, let's say, for example, let's say, for example, you're given a function which is y equals to sine x. So I think this is something that you all familiar with. So if you're given a function, usually when we want to draw or represent the function graphically, what we do is to have a table. And in that table, we have an input, which is our x value. So the x value represents our input, and then our y value represents our output. So if you take a value of x and you plug it into your function, then use a calculator, then you will get an output of 0. So this is your input and output. Let's note that because we're gonna need this. Yes, okay. So just remember that this is your input and that's your output. So after you have your input and your output, but they'll probably give you a range of the graph, then you will have your x and y coordinates, and then you will plug in the values, your 0 going with your 0, and then in terms of your pi, you have your pi and your corresponding y value, and then you will make draw a line connecting all the points, and you will have a function that looks like this. So, but then the one thing I need you to remember right now, it's your input and your output, because it's very important when you calculate limits to know which one is your input and which one is your output. So we can note this down maybe and say, okay, so this is your input. Sorry about that. So this is your input and this is your output. This is your output. Okay. So now, sorry. So now that you have your input and your output, and then you can draw your function, and the function of sine x looks something like this. Then, let's say you're given, let me do that. Let's say you're given a function, sorry about that. Okay. So if you're given a function, for example, what's supposed to show here? Gosh. Please bear with me, it's my first day. First days are the hardest. So yeah, okay. So let's say you're given a function which is, so let's say you're given, oh gosh. Sorry about this. So you're given so your function is x squared plus 4x plus 4x minus 12. All of this divided by x plus 6. Okay, so let's say you're given this function, which is x squared plus 4x minus 12 divided by x plus 6. So what someone would do is to factorize. So knowing that this is your numerator and this is your denominator. So what you would do is to factorize the numerator, and then you would probably assume that, okay, now this one, okay. So you just say, okay, now that I factorized my polynomial, then I'm gonna cancel this and that, remaining with what? With y equals to x minus 2. And then what someone would do is that after they cancel that, the numerator and the denominator, they would write the final answer as y equal to x minus 2, and they would try to draw this function, which would give them something like this. But what I need you to know is that if you're given this function, you don't automatically go to that, because sometimes you have a function that is not defined at a certain point. For example, if you look at this point, I want you to focus at this point, because I'm going to quickly show you how we're supposed to do it the correct way. So I want you to focus on this point. But I know that most of you, if you're given this function, this is the procedure you're going to follow, that, okay, I know if I'm given something like this, I need to factorize, and then after factorizing, then I look at the common terms, cancel them out, and then remain with this, and then draw my function. But then what you're actually supposed to do is, remember that if you substitute the value -6, remember when you draw a graph, you have to check different points. Like, remember how I showed you with this one. I showed you that to draw a function, you need to have inputs and outputs, and see which, like when you substitute your input, which output you get. So in the case of this function, if you substitute your value of -6 here, substitute the value of that, or maybe if you use the factorized form, which is this. So if you use the factorized form, please note that it's this one. So if you use the factorized form of your function, if you plug in the value -6 in the place of x, which is your input, what you will actually get is 0 divided by 0. So what that means is that your function is undefined at this point where x equal to -6. So that's why you need a table to check if for every input do you have an output. But then in the case of this function, if you put in x as your input into the function, you will get 0 divided by 0, which means your function is undefined at this point. So you will probably ask yourself, okay, now, if my function is undefined at this point, how do I represent it on my diagram? And this is what you're supposed to do. So what's actually happening is you need to represent, you will still have the same graph, but then at this point, you need to indicate, oh gosh, okay. At this point, you need to show an open circle which shows that your function is undefined at this point. So a solid line means your function is defined at that point, but then an open circle means your function is undefined. So we don't know the exact value at this point, the value of x of y at this point. Okay. So what you need to do is, okay, so now, okay. So what we are interested in is, okay, now that we have a function that has an open circle, what does that mean? It means we need to check what happens to the value of y when we approach this point. So, oh, and another thing to note is that this example is actually from your book. So if you put in values of, oh, okay, there's a note. Okay, let me go back quickly. There's a question about why am I calculating x again? What this is, this can you hear me, guys?
Okay, yeah, you were muted, but I unmuted you. It's fine now.
Is it fine now?
Yes, it's fine.
Was I muted the whole time?
No, you were not muted the whole time. I think
Okay, okay.
I don't know who muted you.
Okay then. Okay, guys. Continuing. Oh, so I was explaining that this is actually your input. What's happening?
Not to press. She must not press anything. Can you share your PowerPoint again?
Okay, that's what I'm trying to do, but I can't go back from my side. Do you want to keep ink? Okay.
You can't go back.
Okay, that's fine. Is it fine now?
No, I can't see your PowerPoint. Can you
You
press
can't
on?
see. Okay. Let me try to share my screen again. You still can't see it.
No, nothing.
Share. Can you see it now?
Yes, there we go. It's fine now.
Okay, and can the students see what I'm doing?
Yeah, I believe so.
Okay. Okay, so let me just go back to the slideshow. We are back. I think there was a glitch somewhere and you couldn't hear me. So what I was saying is that if you look at your value of x equal to -6, I'm just checking if I take my value of -6, and substitute it into the function, which I simplified, which output am I going to get? So this is actually y. Back to So this is actually y equals to the 0 that you're going to get from saying 0 multiplied by -8 divided by 0. So what happens is at the point -6, so if I put in the value of -6 into my function, I will get 0 divided by 0, which is undefined. So how you represent undefined on your diagram, it's by going to your graph, and then where there's the value of 6, of -6 in this case, let me show you. So the value of -6, which is your x, is undefined. So this is why we have a blank dot. So you don't have a corresponding value of y when you plug in -6 into your equation. Okay. So for example, if you plug in the value -9, you'll have -9 plus 6. So if you take in the value of -9 and you plug it into your equation, you'll have -9 plus 6 multiplied by -9 minus 2, all divided by -9 plus 6. So if you do the calculations, you'll get -11. So for all the values, if you look at this table, it doesn't have the value of 6, because if you plug in 6 into the equation, you will have an undefined value. But then with regards to limits, what we are interested in is what happens when we approach this undefined value. So we create a table with different values of x in this case. So you have different values of x and your output. So remember, this is your output. So I'll represent this with a different color. So this is your output, and then this is your input. Okay, this color. So these are your outputs. Sorry about that. So these are your outputs, and the red one represents your input. So if you plug in the value of -9, you'll get -11. If you plug in -8, you'll get -10. But we said that if you plug in -6, you will get an undefined value. So what we need to check is, okay, what happens at that point? What's actually happening at that point? That's why we have this table to check that. So if you look at when you plug in values of, so our 6 is somewhere here. So the value of 6 is somewhere in between here, but we don't know the exact value that of y that corresponds. But we can see that. So we need to check that, okay, when we approach 6, what happens to the value of y, isn't it? So when you approach 6 from the left and from the right. So I'm going to show you from. So we need to check what happens to the value of y. Okay. I'm not sure. Okay, now. Okay. So if we plug in, let's say we're coming from the negative side of 6, from the right side of 6, which is this side. So if we're coming from this side, approaching 6, what happens to the output? And if we're coming from this side, okay, we need to check what happens. Okay, so if you can look at your Y value, remember we are interested in our Y values. So if you're approaching 6 from the right, which is this side, so you're approaching 6 from the right. Just want to finish this quickly, so maybe we can go to questions. And then we're approaching 6 from the left. Okay, so if you look at the graph, if you're approaching the value of 6 from the left, which is from this side, your value of Y approaches 8. And if you're approaching from the left, you're still getting a value of 8. So the reason why, so how we represent that is the limit of a function. Our function in this case is this x plus 6, x minus 2 divided by x plus 6 from the left and right. Then you get -8. So that's why -8 is your answer. And if you approach a limit from the left and right and you get the same value, we say the limit exists. Okay, so let me see if I can answer your questions with what we've done so far. So please bear with me. It's my first time and I'm trying to get a hold of a hang of how everything we need. Okay, can okay, so this is how we represent the limit. So the limit is practically saying, okay, what happens when I approach the value of Y from the left and right? So when you approach the value of -6, you are approaching the value of -8, but you don't know the value at this point. So I'm trying to see how I can get you guys to ask questions so that I can explain some of the things we've done today, so that you flow with me. Can you still hear me, guys? Okay, so moving on, because I was trying to see if you have questions that I can quickly ask. Okay, so someone said I should explain the left and right thing. You are given a function, isn't it? No, it's not about what the graph will exceed or not. What we are interested in is what happens when you approach this undefined value. Because remember, you don't have the exact value at -6, but you know the value of y closer to -6. For example, the value of when you plug in -6.08, your output will be -8.08. When you plug in this value, this will be your output. But then when you plug in -6, you will get 0 divided by 0, which is undefined. Hence, we put an open circle to represent that. But then if we didn't want to represent our answer graphically, we do that by using the limit. So the limit actually tells you if what is limiting this function. So if you have a function, but you have an undefined value at that point, you can represent it to say, okay, this is what my function is approaching at this point. But you can also represent graphs that do not have open circles with limits. So your limit is just practically telling you that what are you approaching when you get closer and closer to this point. Let's do a different example and you will see. Let me see. Let's say, for example, with this function, isn't it? What you need to check is, okay, so the left and right is just to explain whether the limit exists or not. So for example, with this function, if you're approaching this function, okay, let's say this is, so in this case, you're given a function and you need to check what it's approaching. So we're checking what happens to this function when we approach 0 from the left and right, isn't it? So you need to check what we are approaching. So we are approaching 0. And the approach is represented by this negative sign and the positive. So if you approaching from your right, from the right side of the graph, so left. Okay, what time do we have? So if you're approaching from the left, you are approaching -2. But then when you approach from the right, you get +2. That's why I also mentioned that if you look at the example in the textbook, there's an error. You have -2 when you approach from the left and right. So the textbook I'm using is the Siavula one. So if you approach from the, if you have a function, remember the approaching part, we're looking at the y value. So when your x gets closer and closer to 0, what happens to the value of y? When x gets closer to 0 from your right, so you're looking at the x value. So if my x approaches 0, what happens to my y? In this case, your y approaches 2, gets closer and closer to 2, which is the positive one from the positive side. But then from the negative side, which is your left, when you get closer and closer and closer to 0, your function approaches what? -2. And if the limit from your right and your limit from your left have different values, like in this case, we say the limit does not exist. Yes, your limit, so you're checking your x value. What happens to my x value? So if I change my x value, which is this part, what happens to my y value? When I change my x value, what happens to my y value? And the answer that you get, it's for your y value, not your x value. That's very important. So you're changing values of x, which is your input, to get values of your y. You're changing values of your x to get values of your y. I just wanted to show you because there's an error in your textbook. Just need to confirm the page number, but there's an error in your textbook where they're saying when you approach from the left and right, you're getting the same value, but you're actually getting different values. Yes, your limit is determined by your y value. You're checking what happens to, so you're actually checking when I change my x, what happens to my y. I'm trying to get my host to help me with unmuting you guys so that I can just get your questions and then try to answer them. Okay. Yes. So for your homework, I need you to check. So you need to go to your textbook. This is actually from your textbook. So you need to check, okay, so we'll do this when we start tomorrow. You need to determine whether the limit of a function exists or not, and you show that with a graph, and then you show how you got the answer. So this one, you have to check what happens to sine x when x approaches pi, what happens to cos x when it approaching 0. I don't see this. I think okay. I need to. Crap. No. Okay, guys, I need to, because I'm trying to. Yes. Crap. So sorry about this, guys. Like, I'm really trying to get the hang of this. So, but then this is your homework. I hope you noted it down. So tomorrow we'll start with that, but we can just review some things before we go into the homework. So maybe the confusion here was this part. You're actually checking your y value, because I can see a lot of you are asking, okay, which value do we actually check? So this part shows you what x is approaching, and your answer shows you what y is approaching. Does it make sense? I hope it makes sense. So your x value approaches a certain value. This is how the notation looks like. And then your y value, the value the function approaches, is your answer. Same thing in this case. You are approaching 0 when in the x-axis, but then your y value is approaching -2. When you're approaching 0 on your x-axis, your y value is approaching +2. And if the limit from the left is different from the limit from the right, then we say the limit does not exist. So you need to check your limit from the left and right. So it does not exist because this is +2 and this is -2. But then with the previous one, oh, I didn't show you. You have -8 from the right. So you're approaching -8 from both sides. Yes.
Ma'am?
Yes, I can. Can you hear me?
Yes, we can.
Okay, okay, good.
I still don't understand how you got to the -8. I understand that you used 6, but I mean the -6, but I still don't understand how you got to the -8.
Okay, remember the negative, if you go back to the equation, this is the function you were given, isn't it? You were given x squared plus 4x minus 12, which is that. But then we simplified the given function. Do you agree? So after simplifying this, we substituted the value of -6. I hope you understand. So when we substitute the value of -6, you get 0 divided by 0.
Mm.
So you do not have a value of y corresponding to the value of -6. Eh? By then, you want to know, okay, if I don't have a value at that point, what happens when I move closer and closer to that point? So if you look, I think it's because I'm also not using different colors. But then if you look at the x values, so from -9 to negative, let's say 6.01, you're actually approaching the value of x from your left, isn't it? So if you're approaching the value of -6 from the left, what happens to the value of y? You're approaching 8. Can you see that? You moved from 11 and you're moving closer and closer and closer to what? To 8. And then the same thing, if you come from the other side, which is your right side, if you start with -3, -4, and you substitute into your output, remember, x is your input, y is your output. If you plug in the value of -3 in this equation, you will get -5. -4 into this equation, you will get -6. And as you move closer and closer to 6, your value of y is approaching what? -8. So that's why we're saying the limit as x approaches -6. So we are approaching -6 from the left and right on the x-axis, but then we need to know what happens to this function. It's approaching -8. So when you approach -6 from the left, and when you approach it from the right, you get which value? You get -8. Does it make sense?
Is it also possible that I can use the -2? I mean, yeah, the 2 from the other side, like since x is +6 or x is 2.
You want to use -2 as what? The value you are approaching on the x. So you are asking what would change if, let's say, your limit is x approaching -6. Is that your -2? Is that your question?
Yeah, because at this point, my x is equals to -6 or my x is equals to 2, right?
No, I think you're looking at your factors. You are factorizing and trying to say x plus 6 equal to 0. That's what you're doing, isn't it?
Yeah.
No. Remember when I started the question, I think maybe because I didn't come out. Okay. Going back to this question, you are given x squared plus 4x minus 12 divided by x plus 6. You normally, when you're given a function, you plug in different values of x to get corresponding values of y, isn't it? So that you can plot the graph, isn't it? But then in this case, when you plug in the value of -6 into your equation, you will get 0 divide 0, which is undefined. But then because you don't have an exact value at that point, you want to see what happens when I get closer and closer to the -6. Because you don't have the exact value. Hence, we represent it with an open circle. So you interested in what, so how you represent what happens when you approach from the left and the right. This is how you represent what we were doing here. I think maybe when you go through, hello?
Ma'am,
Yes. Is that
I wanted to, yes.
okay,
Ma'am, I
Kisa?
wanted to ask, so for the homework, the first one, C, would you then multiply the denominators by 3x so that you
Okay.
can,
Let's go quickly. Okay, from the homework you have sin x, where you're checking x approaching pi, isn't it?
yes.
Go there. Sorry about that. Okay. In this case, we are approaching pi. So you'll check what happens when you approach pi from the left and right, isn't it? So what will happen is you're checking what, so you're approaching pi and you are approaching pi from your right, isn't it? So this is from the right and this is from the left. Do you agree, Kiza? Okay, so now your value of y will be 0 because the value of y gets closer and closer to 0. Let me use a different color for this. So let's use a different color.
Ma'am,
Yes.
I'm confused because I don't know whether we're supposed to factorize first.
Okay, the factorizing part, I was showing you that if you're given this function, isn't it? Kiza, can you hear me?
Yes, I can.
So if you're given this function, someone would factorize and say this is their answer, but this is actually not right because this function, which is x squared plus 4x minus 12 over x plus 6, is not defined. Hence, I highlighted that it is not defined at -6. So you're supposed to represent, it's going to be the same graph, but then with an open circle to show that it's not defined at that point.
Okay. Okay.
Okay.
Okay.
So doing it this way would be wrong because you would actually write the function of y equals to x minus 2. But the right way of doing it is plugging in different values of x in the original equation. So when you plug in different values, you will find that when you plug in the value of -6, you will get an undefined. And how you represent undefined is by putting a open circle, because you can't write undefined on the graph. So how we represent that is by showing an open circle.
Okay, makes sense. Thank you, ma'am.
Okay, pleasure. Let me just write a note here that this means it's undefined. Oh, not bad. Eraser.
Ma'am, may you please share your slides and
Okay.
with your notes on it?
Okay, I'll find out how to do that. So I'll try.
I mean, like,
But
maybe
then, or you can actually watch the video after. Can you hear me?
Yes.
Yes, and in the
Yes,
chat,
ma'am.
I'm gonna quickly type in my email address so that if you guys have questions, you can ask me later. But then I'll also add that on the slides. But I
Okay,
know
thank
it's a new concept, so some of the things are confusing. But what I wanted you guys to see today is that you have points on a function, on a graph, which are defined and some which are not defined. And the limit is just interested in what happens when you approach a certain value, like we did with the sine function. So with a sine function, you have, let me check quickly. You have values everywhere. So you don't have open circles because every value of X has an output. So you have an input, output, input, output. But then you can also write this in the form of limits. So this would be the limit. Please excuse my writing. So the limit as X approaches pi from the left of the function sine X equals to 0. And then the same thing, the limit as X approaches pi from the right of sine X, so it's not neat, of sine X is equals to 0. Because your value of y goes to 0, your value of y goes to 0. But then the x value approaches pi from the left and right. So this will be, so your final answer, so your final answer will be that the limit is defined because your answer from your left and right is the same. So your final answer of the limit as x approaches pi of sine X equals to 0. That's your final answer. So this is what we're gonna do for today. So tomorrow we're gonna start with the homework solutions, just to make sure that you understand what happens when the limit. But remember, this, you do not do this. You do not factorize and give this as your answer. This is not right. The right way of doing it is to check at the different points. Okay, if I substitute 1, what happens? If I substitute 2, what happens? If I substitute 3, what happens? So if it's undefined at that point, that's what you show. So I will find a way to share the note with you, but I will also re-explain the approaching from the left and right, and then so that you can understand it better, because we're gonna need it when we do derivatives, when we move on with the chapter. So please remember, just try to do this because we already did this. So I'll see you guys tomorrow, but then we'll just start with the homework problems. This is in your textbook. So remember, textbook page 211. And then you attempt this, and then we'll do the cos x one. So I'll see you guys tomorrow, and I'll try to find a better way to explain the limits and the approaching. Thank you so much.